Good morning, everyone. My today topic is classification of chopper. Classification on the basis of use. So here is there are different type of chopper. Type A chopper, that is called first quadrant chopper. Type B chopper, second quadrant chopper. Type C chopper, second quadrant type A chopper. Okay. Type D chopper or second quadrant type B chopper, type E chopper or 4 quadrant chopper. Okay. So this type A chopper has two name, type B chopper has two name, and type C chopper and D and E chopper. Okay. Type A chopper. Let's start with type A chopper. This is the circuit diagram of type A chopper. When this is also called first quadrant chopper. See how when CH1 is on, when this is on, so what happened? This diode is reverse bias. Current, when this is on, current will flow from here to here like this. Output plus V0 minus, then so what we see, V0 equal to Vs, and I0 is positive. Current is flowing in this direction, I0 is positive. Okay, I0 is positive, I0 is positive. When suppose when CH is off, is not connected, CH is off. So then what happened? When CH is off, then this load contain a inductor. Have an inductor. Suppose we draw the inductor in this manner. This inductor charge for this polarity. Okay, when CH1 is off, then this inductor will discharge, which is the inductor of the load. This will discharge in this polarity. So what happened? This FD will get on, and output voltage V0 is 0 and I0 is constant. I0 is flowing in the same direction. Okay. Power flow from source to load. Means power flow from source to load. No power is flowing from load source. Okay. This is the type A chopper. Type B chopper. This is type B chopper. This is the circuit diagram. Type B chopper or second quadrant chopper. Type B chopper or second quadrant chopper. This is the circuit diagram. Let's operate the circuit diagram. When CS2 is on, assuming that at the starting the EMF E is charged or E is charged. Okay. When CS2 is on, what happens? Current will flow in this direction like this. Okay. So the conventional current I0 I denoted like this. So I0, when CS2 is on, current will flow in this direction. So according to this I0, this current is negative. That's why it is in second quadrant. Let's have a pause. Voltage. When CS2 is on, V0 is 0. And I0 flow through this inductor E and CS2, and this inductor will store energy. Now, when CS2 is off, what happened? When CS2 is off, this inductor is storing energy in this polarity, in this form. When CS2 off and flowing a current I0 in the opposite direction, When CS2 is off, what happened? This current I0, start to reduce. So what happened? This inductor will deliver its stored energy to the circuit in this polarity. So this voltage is E plus LdI by dt, which is greater than Vs. D will conduct. So voltage is positive. This plus minus, output voltage is positive, but current is negative. Okay. Power flow from load to source. This type of chopper is used to collect or convert stored energy of motor into the electrical energy. Okay? So this type of chopper are used in DC machines. Okay, and you also use to fully control the DC machine. This is type B chopper. Let's see type C chopper. Type C chopper. This is the combination of type A and type B chopper. When CS2 is on and FD is on, V naught equal to 0, V naught is 0. When CH1 is on or D2 is on, when this is on and these both are off, then V naught equal to Vs. V naught equal to Vs. Let's see how they are operate. For CH1 means for CH1 is on. Suppose when CH1 is on and all other are off. CH1 only CH1 is on and all other CS2, D2 and FD are off. Then output voltage V naught equal to Vs and current flowing in this direction. Current flowing in this direction like this and this. Okay? The current flowing in this direction, V naught is V naught equal to Vs and I naught is positive. Suppose CH1 is off and at this time inductor is storing energy in this polarity. When CH1 is off, what happened? This inductor deliver its energy in this format, in this polarity. What happened? This FD will get on. Then output voltage V naught is 0, but current is continuous in the same direction. Current will continuous in the same direction. So CH1 is on or FD conduct, the current will always positive and will voltage otherwise positive or 0. For CH2, suppose at the time CH2 is on. Okay, CH2 is on. At that time, this inductor is charging. This inductor is charging through this E, with the polarity of VL minus like this. Okay, this inductor is charging through this, through CS2. Current is flowing in negative direction. Current is flowing in negative direction. This and this. So output is equal to this plus this. Output is equal to 0 because CS2 is short circuited. Output is 0. Output is 0 and current flowing in opposite direction. Now if CS2 is off, all other devices are also off. So when CS2 off, what happened? This inductor charging with this polarity. When CS2 is off, this inductor deliver VL plus minus, like it change the polarity of inductor in this manner, plus and minus. Then what happened? This diode D2 start to conduct because this is plus and this is plus terminal. D2 start conduct. At this time, D2 current flow through like this and this. CH2 off and D2 on. D2 is on because of CS2 is off. Okay, so current power flow from, in this condition, power flow from load to source. When CH1 is on, then that time power flow from source to load. In this condition, when CS2 is on, power flow from load to source. Okay. One more thing is that CH1 and CH2 cannot be operated simultaneously as it short circuit the supply voltage. When you turn on both CH1 and CH2, what happens? This supply voltage gets short circuited. So this is the type C chopper. Now see type D chopper. This is type D chopper. In this chopper, this is the circuit diagram containing two diodes and two CH1 and CH2. Two diode and two chopper. When CH1 and CH2 is on, then current will flow from here to here to here, like this. So you can say that V polarity is V0 plus minus this, and current is this. So V0 equal to Vs and I0 is positive. I0 is positive. Okay. Now suppose this load having inductor. Suppose this is connected in this manner, having inductor. So what happens when you see of CH1 and CH2? This inductor was charged through a polarity of this. When you switch off CH1 and CH2, what happens? This inductor stored energy of inductor will deliver in the circuit in this polarity. Okay. So what happened? D1 and D2 gets turned on. This is plus VL minus. Current will flow like this. So in this condition, in this case, you can see that polarity of current is same. Means I0 is positive in this condition also, but V0 is negative. Because inductor changes its polarity to this, from this to this. So V0 is negative. But more thing is that suppose when CH1 is on and off, you make CH1 and CH2 on and off. So suppose you turn on CH1, turn on time of CH1 is greater than turn off time, like this. Turn on time is greater than turn off time. Okay? Then output voltage is positive. Because this in this time stored energy or power flow from load to source, and in this time power flow from source to load. This condition, when turn off time is greater than turn on time, or you can say that turn on time is less than turn off time, then you say that output voltage is negative. Means this turn off time is greater than turn on time. It stored energy in the inductor will return back to the source. So if you find the average of this equation is this waveform, you can see that the resultant output voltage gets negative, and you can also understand why they're saying the waveform. So this is the type D. In this lecture we discussed type A, type B, type C and type D type chopper. In next lecture we will study type A chopper. Thank you.